Hello students, today we will be doing the NCRT solutions for triangles and its properties chapter from the NCRT part, right? So we are starting with the exercise 6.1 quickly. So this exercise is based on the median, right? The median is nothing when we draw a line from a vertex to the opposite edge and which divides that particular edge into two equal halves, that is known as a median. So if we talk about question number 1, PM is, so PM here is as PM is forming a 90-degree angle over it, so PM is a altitude here. Right? And PD, if we talk about, as it is written that D is the midpoint of QR, so that means QD is equal to DR. So PD will be equal to, PD is the median here. Is QM equal to MR? No, it won't be equal. We'll be writing no, QM is not equal to MR because as it is already given that D is the midpoint of QR. Next, we move on to the question number 2, which says draw a rough sketch for the following. So if we here you need to draw a triangle ABC in which BE is the median. A part is you need to draw a triangle. I've drawn ABC in which BE is the median, so I can draw BE here. B part says in triangle PQR, PQ and PR are the altitudes. So that means if they are altitudes, so it will be forming a right angle triangle, and right angle should be there at P. PQ and PR are the altitudes. Next is C part says in triangle XYZ, YL is the altitude in the exterior of the triangle. So if we draw any obtuse angle triangle, we say this is X, this is Y, this is Z. So altitude of this particular triangle will be lying outside, right? That becomes YL is the altitude here. Next, we need to do the quotient verify by drawing a diagram if the median and altitude of an isosceles triangle can be same. You can just draw a line segment PS which is perpendicular to BC. Any triangle you can draw here to solve this particular question, right? Let's move on to the exterior angle triangle property of a triangle, exercise 6.2 now. Exercise 6.2 says, find the value of the unknown exterior angle. Actually, exterior angle property says the exterior angle of any triangle is equal to the sum of the opposite interior angles, right? If I talk about the third part, the value of X will be equal to the angle, the sum of 30-degree plus 40-degree because of exterior angle triangle property. So ultimately, X value will be equal to 70-degree. So all the questions can be done using exterior angle triangle property. Let's come to question number 2. Sixth part. Now in the sixth part, that is also the exterior angle triangle property is working here. We can find the value of X. So now X plus 35. X and 35-degree are the interior angles will be equal to 75-degree because of exterior angle triangle property. So X will be ultimately equal to 75-degree minus 35-degree, which is 40 degree. Let's move on to the next exercise, that is exercise 6.3. Which is based on angle sum property of a triangle. if we talk about question number 1, I'm taking fifth part. Now, if we talk about in the fifth part, if we see all the three angles, interior angles are x degree each, right? So the sum of all the interior angles is always 180 degrees. So if we total them up, that should be equal to 180 degree because of angle sum property of a triangle. So this will be equal to 3x equal to 180 degree. X will be equal to 60 degree each. So every angle will be of 60 degree here. Let's take sixth part also. It is a right angle triangle given to us. One angle is 90 degree given to us. Next is one is 2x and another is x. Let's total them up. One is 90 degree plus x plus 2x is equal to 180 degree because of angle sum property of the triangle. So 90 plus 3x is equal to 180 degree. 3x will be equal to 180 degree minus 90 degree, which is ultimately equal to 90 degree. So x will be equal to 90 divided by 3. So x will be equal to 30 degree. So the value of the angles, x is 30 degree and 2x is double of 30 degree, which is 60 degree. Let's move on to question number 2. Find the unknown values of x and y in the following figure. Let's take third part first of all. First of all, in this question, we can find out the value of y using the angle sum property. And then by exterior angle property, we can find the value of x, right? Otherwise, we can do one more way here. We can find out the value of x using the exterior angle property. And then the value of y using linear pair, right? So x is equal to 50 degree plus 60 degree. So x, the value of x is equal to 110 degree because of exterior angle triangle property. Now x plus y, because they are lying on the straight line, their sum will be equal to 180 degree because they are forming a linear pair. So x is 110 degree plus y, which is equal to 180 degree. So y will be equal to 180 degree minus 110 degree. So that is 70. Now let's come to the sixth part here. You can see from here, x will be equal to y, right? Angle x will be equal to y because of vertically opposite angles. Now all the angles will be x only. This will be x. This will also be x, right? So all the interior angles of the triangle will be x. We can say that x plus x plus x is equal to 180 degree because of angle sum property of a triangle. That is equal to 3x equal to 180 degree. X is equal to 180 divided by 3, which is 60 degree. And ultimately, value of y and x are same, so y is also 60 degree. We got the values of x as well as y here. Let's quickly move on to the next exercise, that is based on exercise 6.4, which is based on the triangle inequality part. So if we talk about the first portion here, first question says, is it possible to have a triangle with the following sides? So when the question comes with if it is possible to form a triangle with the following sides, what you can do, you can check this, you can use the property that the sum of two sides of a triangle should always be greater than the third side. So if I take question number 1, first part only, we are having 2 centimeter, 3 centimeter and 5 centimeter. So if you find out the sum of 2 and 3 sides, which is ultimately equal to 5 centimeter, which is equal to the third side only, which is 5 centimeter. So here the sum of two sides of a triangle is not greater than the third side. Of a triangle. So the formation of triangle is not possible. You can write down, so it is not possible to draw a triangle whose sides are 2 centimeter, 3 centimeter and 5 centimeter. Now if we talk about question number 2, that is very easy. You all can do it. We are moving on to question number 3 now. Question 3 says AM is a median of a triangle ABC. Is AB plus BC plus CA is greater than twice of AM. So as we know that the sum of the length of any two sides is always greater than third side. So if we consider the triangle ABM, so we can write down AB plus BM should be greater than AM. We keep this equation as 1. Now we consider a triangle ACM. Their AC plus CM should be greater than AM. This has 2. Now we can just add 1 and 2 equations. So whenever we are adding the equations, we'll just add the left hand side to the left hand side, right hand side to the right hand side. So this will be AB plus BM plus AC plus CM is greater than AM plus AM. So this will be twice of AM. Now BM and CM if you add, so that will be equal to BC. So you can just replace it that AB plus BC plus AC is greater than twice of AM. So hence it is verified. You can write down hence 2. Now let's come to the next question. Question number 4. Question number 4 says ABCD is a quadrilateral. We need to find AB plus BC plus CD plus DA is greater than AC plus BD. So as we already know, the sum of the length of any two sides is greater than the third side. Now we take a 1-1 rectangle. First we are taking in triangle ABC. So that we can say that AB plus BC is greater than AC. Keep it as 1. Now I take the triangle in triangle BCD. BC plus CD is greater than BD. Keep it as 2. Now in triangle CDA, CD plus DA is greater than AC. Keep it as 3. After this, we can take in triangle DAB, AD plus AB is greater than BD. This is 4. Now you can just add all the 4 plus 2 plus 3 plus 4. If we are adding all the 4 equations, so what we'll get, we'll just add left hand side to left hand side. AB plus BC plus BC plus CD plus CD plus DA plus AD plus AB is greater than AC plus BD plus AC plus BD. Now you can check AB is 2 times, BC is 2 times, CD is 2 times and DA is 2 times. So that will be 2AB plus 2BC plus 2CD plus 2DA is greater than twice of AC plus twice of BD. You can take 2 common. You can take AB plus BC plus CD plus DA within the bracket, which is greater than 2 again common, AC plus BD. And now you can just cancel 2 and 2 on both sides. So ultimately our answer comes out equal to AB plus BC plus CD plus DA is greater than AC plus BD, which is the quotient which is given to us. So it's hence true. Now let's come to question number 5. ABCD is a quadrilateral. Let us quickly draw a quadrilateral ABCD. Join their diagonals as well. The joining point I'm taking it as P. Right? So we need to find that AB plus BC plus CD plus DA is lesser than twice of AB plus AC plus BD. So what we can do, we use the same property, the sum of the length of any two sides is greater than the third side. So we'll take up the triangles as PAB. In triangle PAB, we can take it as PA plus PB is greater than AB. Next, we take triangle PCB. Keep this equation as 1 here. So in triangle PCB, if you see PB plus PC is greater than BC. Keep it as 2. Now in triangle PCD, PD plus PC is greater than CD. Keep it as 3. In triangle PDA, PD plus PA is greater than AD. Keep it as 4. Now just quickly add up all the 4. 1 plus 2 plus 3 plus 4. So PA plus PB plus PB plus PC plus PD plus PC plus PD plus BA is greater than AB plus BC plus CD plus AD. Now if you just join PA and PC, that becomes AC. And PB and PD becomes BD. So PA और एक PC join करते हैं तो that becomes AC. Again we have one more PA and PC, that becomes AC. Now if you are joining PB and PD, that becomes BD. PB and PD, that becomes BD, which is greater than AB plus BC plus CD plus AD. Now AC plus AC is twice AC. BD plus BD is twice BD, which is greater than AB plus BC plus CD plus DA. You can take 2 common here. AC plus BD is greater than the sum of all the 4 sides of the quadrilateral. So it is proved. After this, let's move on to the next question. Now, question 6 says the length of the 2 sides of a triangle are 12 centimeter and 15 centimeter. So, between what range the third side will fall? That will fall between 12 plus 15 is 27 centimeter and 15 minus 12 is 3 centimeter. So, the third side will fall in the range of 27 centimeter and 3 centimeter. So, we can write down third side will be between 3 centimeter and 27 centimeter. Now let's come to the next exercise, which is exercise 6.5, I suppose. That is related to hypotenuse, the Pythagoras theorem, which actually says the sum of the hypotenuse in a right angle triangle, the square of the hypotenuse in a right angle triangle is equal to the sum of the squares of perpendicular and base. I'm taking question 3 first of all from this. A 15-meter long ladder, as the figure has been shown to you, reached a window 12-meter high from the ground on placing it against the wall at a distance of A. Find the distance of the foot of the ladder. So when we need to find out the distance of the foot of the ladder, what we can do, we can use Pythagoras theorem using Pythagoras theorem, which is h square is equal to p square plus b square. So 15, the ladder is the hypotenuse. This is 15, this is 12, and this is 8. So 15 is the hypotenuse. We can say that AC square is equal to AB square plus BC square. So AC is 15 square equal to 12 square plus A square. 15 square is 225, 12 square is 144 plus A square. So if we need to find the value of A square, so A square will be equal to 225 minus 144. So A square is equal to 81. A will be equal to 9 meters. So the distance of the foot of the ladder from the wall is 9 meters. Next, we take up the question number 5. Question 5 says, a tree is broken at a height of 5 meters from the ground and its top touches the ground at a distance of 12 meters from the base of the tree. Find the original height of the tree. So there is a tree which is broken at a height of 5 meters from the ground. Means I am taking it as P, this as A, B, C. Okay. So it is saying so the particular question is saying that the tree is breaking from a point B, right? So what we can do, we can write down the statements as This tree is forming a right angle triangle here. So this is 5 meters. Top touches the ground at a distance of 12 meters. So this is 12 meter given to us. First, we need to find this using the Pythagoras theorem. You can write down. Let B be the point where the tree is broken. At the height of 5 meters from the ground. Tree top touches the ground at a distance of 12 AC, which is equal to 12 meters from the base of the tree. Now triangle ABC is a right angle triangle. Using Pythagoras theorem, BC square is equal to AB square plus AC square. So BC is actually, we do not know, so BC square will remain as it is. AB is 5 square plus 12 square. So 5 square is 25, 12 square is 144. So BC square is actually equal to 169. So we can say that BC is equal to 13 meters. Then the original height of the tree is equal to AB plus BP or BC. AB plus BC, which is equal to 5 plus 13, 18 meters. This is the original height of the tree. Practice. These are the practice questions that you can do from this chapter, which are, as per examination point of view, they are very important. So you can just practice this all. So we'll take up the new revision class in the next video. Take care, everyone. Have a very good day. Bye-bye.